Find the vertices and foci of the following ellipse. Graph the equation. Before we work with this equation, let's focus on the two orientations for the ellipse. These equations are x minus h squared over a squared plus y minus k squared over b squared equals 1. And the other one is x minus h squared over b squared plus y minus k squared over a squared equals 1. So A is the distance between the center and the vertex along the major axis. B is the distance between the center and the vertex but along the minor axis. And the major axis is our longer axis, so A is going to be larger than B. And then we have a value of C over here, and C is the distance between the center and the focus. Now, because our A is in the denominator of the variable x, this equation is indicating a horizontal orientation. So if we were to just sketch a very quick picture of that, we would have a center. C distance away from that center, we'd have foci. And then A distance away from that center, we would have our vertices. And then going in a perpendicular direction, we'd have distance of B away from the center, our minor axis vertices. So we would get this ellipse that is longer horizontally. Then in the other equation, you can see that A is underneath the y. Remember, A is going to be larger than B. So A being under y means that this has a vertical orientation, a vertical major axis. So if I were to sketch that, we would have a center. C distance away from that center, we would have our foci. A distance away from that center, we would have our vertices. And then going perpendicular to that, we would have a distance of B away, our vertices along the minor axis. And this would be a sketch of our ellipse that's oriented vertically or has a major axis that's vertical. So with that in mind, let's take a look at our equation. It's x squared over 4 plus y squared over 36 equals 1. So I can see that the larger value is underneath the y. So this orientation is a vertical orientation, and that's going to tell us what our values of A and B and also our vertex are. So you can see that, or sorry, not vertex, our center. So you can see our center is 0, 0 because there are no numbers added and subtracted inside those squares. And then A squared is going to equal 36, telling me that A is 6. Then B squared is equal to 4, meaning that B is 2. This is going to help us find our vertices, but to find the foci, we have to know the value of C. And that's where this equation comes into play. There is a triangle that's created with A and B and across. This would be A. I think I drew that wrong. Let me fix it. So with B and C, and then going across here ends up being A with a little bit of figuring out. So you end up having a right triangle, and gives us a relationship between A, B, and C with Pythagorean theorem. So using B squared equals A squared minus C squared, we can solve for C. B squared, that'd be 2 squared, equals 6 squared minus C squared. That's 4 equals 36 minus C squared. Can subtract 36 on both sides, giving me negative 32 equals negative C squared. Divide both sides by negative 1 gives me C squared equals 32, and I can square root both sides. Giving me C equals plus and minus 32 is 16 times 2. So that's plus and minus 4 square root of 2. So C is going to be a distance, which is positive. So that's 4 square root of 2. Now that I know A, B, and C, I should be able to find the vertices. So moving from the center, I like to do it with a picture. So from the center, your vertices will be up 6, going up because of the vertical orientation, and up 6 because A is 6. So we would have a vertex at 0, 6, and we're going to go down 6 as well. Vertex is 0, negative 6. For your minor vertices, minor axis vertices, those would be left and right, 2, because B is 2. So the minor vertices would be at 2, 0, and negative 2, 0. And then we can find our foci by going up and down 4 square root of 2. Now let's use our calculator to figure out approximately what 4 square root of 2 is. So 4 square root of 2 is just a little bit more than 5.5. So I'll go up 5, 1, 2, 3, 4, 5, and a little bit more. That brings me to my foci. So that's 0 and 4 square root of 2. And then I'll go down 5 and a little bit more to put me at 0, negative 4 square root of 2. And then I can sketch out with the vertices my ellipse. So this equation has vertices at 0, 6 and 0, negative 6. If you end up counting the minor vertices, which sometimes they do, sometimes they don't, that would be negative 2, 0 and 2, 0. And you have foci at 0, 4 square root of 2 and 0, negative 4 square root of 2. Find an equation for the ellipse. Graph the equation. But before we get to this example, let's take a look at the equations of our two different orientations for the ellipse. So we have one equation being x minus h squared over a squared plus y minus k squared over b squared equals 1. Now the h and the k are the coordinates of the center of the ellipse. The a is the distance between the center and the vertex along the major axis. B is the distance between the center and the vertex along the minor axis. A is always larger than B. And then we have this value of C, and C is the distance between the center and the focus. We have a very similar equation here. The only major difference is the position of A squared and B squared. And in the first equation, A squared is under the X term. In the second equation, A squared is under the Y term. Now that is what indicates to us which orientation the equation has. A is always the larger value, and that'll indicate the longer side. So having an A underneath the X term means the orientation is horizontal, and having an A under the Y term means the orientation is vertical. So if the larger value is under X it's horizontal, the larger value under y, it's vertical. So to sketch out these two, for the horizontal orientation, you have your center. C distance away from that, you have your foci. Then A distance away from the center, so A distance away, are your vertices along the major axis. And then B distance going in a perpendicular direction would be your minor axis vertices. And then your ellipse touches all those vertices to give you the ellipse. For the vertical orientation, you have your center. C distance away, you have your foci. A distance away, you have your vertices along the major axis. Perpendicular to that, you have B distance away, your minor axis vertices, and touch all those vertices to sketch out the ellipse. So for this example, we have a center at 0, 0, and a focus at -15, 0, and a vertex at 17, 0. We want to find the equation of the ellipse and also graph the equation. So what I like to do is to start to put this information on a picture so I can visualize which orientation I'm going to have. So we have a center at 0, 0. We have a focus at -15, 0. Maybe I should count by fives. Say 5, 10, 15. 5, 10, 15. It's going to be symmetric, so you're going to have another focus here. And one more tick mark would get me to 20. And our vertex is at 17, 0. So that would be about here. So based on the placement of these points, I can see that this has a horizontal orientation. And I'm going to use this equation, which has the horizontal orientation. I can also tell what C is. The distance between the center and the focus is C. So since the center is at 0, 0 and the focus is at -15, 0, I know that C is 15. I know that A is the distance between the center and the vertex. So because the center is at 0, 0, and one of the vertices is at 17, 0, then A is 17. Then finally, I can find the value of B using this Pythagorean equation. So we have B squared is equal to 17 squared minus 15 squared. B squared equals, and 17 squared is 289. 15 squared is 225. And then 289 minus 225 is 64, and then I can take the square root of both sides to get that B squared equals 8. Sorry, not B squared, B. B equals 8. So now I have everything I need to write the equation. I'm going to start off with the template, x minus h squared over a squared plus y minus k squared over b squared equals 1. I know the center is 0, 0, so this becomes x minus 0 squared. A is 17, so this is 17 squared. K is 0, and b is 8. Then we can do a little bit of simplifying, and we have x squared over 289 plus y squared over 64 equals 1. So finally, I'll sketch the graph. And I'm going to count by fives. 5, 10, 15, 20. 5, 10, 15, 20. 5, 10, 15, 20. And we have our center at 0, 0. From the center, we'll go left and right 17. So that 5, 10, 15, 17 would be about right here. That's actually negative 17. 5, 10, 15, 17. And then for our minor axis vertices, we want to go 8. So 5 and 8 would be somewhere in between there. And then we can sketch out the ellipse from there. Choose the correct answer below. So we have some equations of different hyperbolas and a picture of a hyperbola we want to match. Before we get to this problem, let's take a look at the template for the equations of hyperbolas. We're going to focus on two orientations. One has a transverse axis that's vertical, and one has a transverse axis that's horizontal. So taking a closer look, we have H and K. H and K are the center of the hyperbola. And we have A squared and B squared. A squared, well, A is the distance between the center and the vertex. Over here we have a C. C is the distance between the center and the focus. And then the value of B sort of defines where your asymptotes are for the hyperbola. So in these two equations, the only major difference is that we have a positive term and a negative term. The first equation has the x term being positive and the y term being negative. And the second one has the y term being positive and the x term being negative. So that's what determines whether you have a vertical or horizontal orientation. So when your x term is positive, you have a horizontal orientation. So the horizontal orientation will have a center and distance of A away from that center, you have your vertices. A distance of C away from that center, you have your foci. And then your B value will tell you how wide to draw these here, because these are going to approach your asymptotes. So you have some asymptotes that go along like this, and how wide those asymptotes are determined by B. For the vertical orientation, you're going to have your center. A distance away from that center, you have your vertices. C distance away from that center, you have your foci. You have your B value, which will help you determine the slope of your asymptotes. And then you're able to draw your hyperbola based on those asymptotes. So for this example, I'm taking a look at the picture, and you can see that we have vertices at 0, 4, and 0, negative 4, meaning the center of this hyperbola will be at 0, 0. That's also going to help us find the value of A to be 4. I can also see that this has a vertical orientation, and I can eliminate these two choices based on that orientation. Having a vertical orientation is having that y term being positive. And then A is going to be determined by the denominator under that y term. So our answer for this one will be y squared over 16 minus x squared equals 1. And that's because our value of A was 4, and that 4 squared is 16 under that denominator. Find an equation for the hyperbola described. Graph the equation. So before we solve this question, let's take a look at the two versions of our hyperbola that we're working with. We have a vertical and a horizontal orientation. So in our equation we have an h and a k, which is the center of the hyperbola. And then we have an a, which is the distance between the center and the vertex. B helps us determine the slope of the asymptotes. And then we have a value of C, which is the distance between the center and the focus. We have those same variables in the other equation, but the major difference is that in the first equation our x term is positive, but in the second equation, the y term is positive. And that's going to help us to determine the orientation. So when our x term is positive, we have a horizontal orientation. When our y term is positive, we have a vertical orientation. So for the hyperbola, for the horizontal orientation, you have your center, a distance away to the left and to the right. You have your vertices. C distance away to the left and to the right, you have your focus. Your value of B is going to help you determine the slope on your asymptotes. Your asymptotes pass through the center. And then from there you have your hyperbola drawn from the vertex approaching those asymptotes. For the vertical orientation, you have your center, and then up and down from that center, a distance of A will give you the vertices. Up and down from that center, a distance of C gives you your foci. Passing through the center, you're going to have two asymptotes. Your slope of that asymptote, the slope of the line that's that asymptote, is determined by the value of A and B. And then you're going to draw your hyperbola using the vertex and approaching those asymptotes. So for this example, I want to first determine the orientation so that I can know which of these templates to use to start building the equation of the hyperbola. So we have a center of 0, 0 for the hyperbola, a focus at 0, 6, and a vertex at 0, 1. So because all of these important features of the hyperbola are lining up vertically, that means I have a vertical transverse axis, and I'm going to use the vertical orientation of the equation. So in order to find the equation of the hyperbola, I need to know the center, which is hk, and these values of a and b. So I can see that the center was given to be 0, 0, so I know the value of h and k. My focus is at 0, 6, so from the center of 0, 0 to the focus at 0, 6, that's a distance of 6. So the value of C is 6. And then from the center to the vertex, that's a distance of 1, and that means my A is 1. So then finally I can find the value of B by using this equation for that involves Pythagorean theorem. So I can use B squared equals C squared minus A squared. B squared equals 6 squared minus 1 squared. That's 36 minus 1, which is 35. So B squared equals 35. I'll take the square root of both sides to get that B is equal to square root of 35. We'll use the positive root since B is a distance. And I can substitute this into the template. The vertically oriented hyperbola, or the not parabola, hyperbola that has a vertical transverse axis. That's y minus 0 squared over a squared, so that's 1 squared. X minus h squared, that's x minus 0 squared, over square root of 35 squared equals 1. And if I simplify, that would give me y squared minus x squared over 35 equals 1. So that's the equation of the hyperbola. Then we want to graph that equation. So I'm going to take the sketch that I've already started. If I have a vertex at 0, 1, I will have another vertex on the other side of the center at 0, negative 1. And then I have a focus at 0, 6. I'll have another focus at 0, negative 6. And then I can use my equation here to find the asymptotes. The asymptotes are going to be y minus 0 equals plus or minus 1 over square root of 35 times x minus 0. That's y equals plus or minus 1 over square root of 35x. I need to find an approximation for 35, square root of 35, so I can sketch this. Square root of 35 is approximately 5.9, so almost 6. So I can use rise over run, or rise 1 and run 6, almost 6. And rise 1, so I'm actually going to go the opposite, down 1 and run 6. So that gives me the negative 1 over square root of 35. And if I draw a straight line going through the center and that point, I'm getting my asymptotes. From the vertex, I can approach those asymptotes and get a sketch of that hyperbola. Find an equation for the hyperbola described. Graph the equation. Before we do this example, let's take a minute to look at our two different orientations for the hyperbola. We have a vertical orientation and a horizontal orientation. So this equation is x minus h squared over a squared minus y minus k squared over b squared equals 1. So the h and k stand for the center of the hyperbola. Then we have a, which is the distance between the center and the vertex. B helps define the slope of the line, that is the asymptotes. And C is the value, which is the distance from the center to the focus. The major difference between these two equations is that the first one has the x term being positive and the second one has the y term being positive. So that whichever one is positive is going to help you determine that orientation. So because the x term is positive on this first equation, this is the equation for the horizontal orientation. And when the y term is positive, that's our vertical orientation. So I'm going to sketch a quick picture so we get an idea of where all the important features are. So for the horizontal orientation, you would have a center, and to the left and right of the center, a distance of A, you would have your vertices, a distance of C to the left and right of the center, you would have your focus or your foci. And then you're going to draw asymptotes using rise over run. And those asymptotes, you're going to use A and B as your slope. And that's going to help define where to draw your hyperbola. Then for the vertical orientation, you would have your center, and up and down from that center, a distance of A would give you your vertices up and down from that center, a distance of c would give you your foci. And once again, through the center you have some asymptotes, the slope of which is defined with a and b. And then from there you can sketch your hyperbola with the vertex and the asymptotes. So for this example, we're given that we have a center at 7, -6, so that tells me that h is 7 and k is -6. We have a focus at 10, -6 and a vertex at 9, -6. I'm going to start to put these points on a picture to help me understand whether this hyperbola has a vertical orientation or a horizontal orientation. So if I start to sketch this, and I'll do a better sketch in a moment, 7, -6, would be the center, and then at 10, -6, we have a focus, and at 9, -6, we have a vertex. So because our important features are lining up horizontally, we know that we're going to use the horizontal orientation of this. If we think about the distance between the center and the focus, that's a distance of 3 points. So our C is 3. And then if we look at the distance between the center and the vertex, that's a distance of 2. So A is equal to 2. Then we can use Pythagorean theorem to help us find the value of B. B squared is equal to 3 squared minus 2 squared. It's 9 minus 4, which is 5. So B squared is 5, making B square root of 5. So now we have the values of h, k, a, and b, and we'll be able to fill in the template of our equation. X minus h squared over a squared minus y minus k squared over b squared equals 1. So that's x minus 7 squared over 2 squared minus y minus -6 squared over square root of 5 squared equals 1. And to simplify that, we would have x minus 7 squared over 4 minus y plus 6 squared over 5 equals 1. So that's the equation of the hyperbola with a center at 7, -6. A focus at 10, -6, and a vertex at 9, -6. Then we're going to sketch a graph of this hyperbola. So I'm going to draw a larger sketch than I started before. So we have our center at 7, -6. We have a focus at 10, -6. And a vertex at 9, -6. Since that vertex is at 9, -6, that was 2 away from the center. If I go to the other direction, so 2 to the left, that would put me at 5, -6 for the other vertex and 4, -6 for the other focus. Then for the, let me show you the equation of the asymptote again. So the equation of the asymptote would be y minus k equals plus or minus b over a. x minus h. So for this example, that would be y minus y plus 6 equals plus or minus square root of 5 over 4 and x minus 7. So those are the equations of our two asymptotes. And you see we needed b to be able to define those asymptotes. And I also need an approximation for square root of 5 to be able to sketch this. Square root of 5, see, this is square root of 5, is approximately 2 1/4. Let me write that asymptote down here so I don't lose it. Y plus 6 plus or minus square root of 5 over 4 x minus 7. Okay, so I need that. I need the slope to help me draw the asymptote. So from the center at 7, -6, I want to rise 2 1/4, so go up 2 1/4 and run 4. 1, 2, 3, 4. That would be approximately about here. And then from the center, I'm going to go down, so that'll take care of the negative. Down 2 and over 4, that would put me about here. And I can sketch out those asymptotes now. And from there, our hyperbola will follow those asymptotes.